Hello everyone, hope you are doing well. So in this video we'll discuss the second problem of Leetcode Weekly contest 350. It's a medium level problem, but I would say easier than the first problem that you got in the same contest, right? That one is tricky. This one is sort of straightforward. Let's see what it is trying to say, okay? The problem name is value of the partition. So it says that you are given a positive integer array nums. Now partition nums into two arrays nums1 and nums2 such that each element of the array nums belong to either nums1 or nums2. Both arrays are non-empty. That means place at least a value in the array, right? That means you can do n minus 1 elements in one array and the last element in the one array. That is done, right? But it should not be empty, it should be non-empty, right? And the value of the partition is minimized, right? The value of the partition is maximum value in nums1 minus minimum value in nums2. Absolute value of this, right? Here max of nums1 denotes the maximum element of the array nums1 and min of nums2 denote the minimum element of the array nums2. Return the integer denoting such partition. Okay. Just see here what it is saying. I have a single array 1, 3, 2, 4. I have to partition these elements into two arrays. Let's call it nums1, nums2. Okay. Such that the maximum value in one array. Look, it can be nums1 or nums2, doesn't matter. The maximum value in one array minus the minimum value in the second array is minimized. Okay, is minimized. That's what I need to do. Okay, so again, seeing the problem, probably it can click you or not, but generally look what I have to do. I have suppose n elements, right? I can partition them for simplicity. I can partition them into n minus 1 elements and one element, right? This I can do. Now all I need to do is max and min. Simple. So I will probably divide it as such like this, right? So first sort it. It is 1, 2, 3, 4. Okay, 1, 2, 3, 4. Now start comparing the adjacent elements, right? Start comparing the adjacent elements. That means your aim is to find the minimum difference between adjacent elements. Why I am doing so, I'll let you know, right? For example, here it is 1, 1, 1 and so on, right? The adjacent difference is same. So that means it doesn't matter how you place the elements. Ultimately you are good to go, right? I mean, what I can do, the maximum in one and the minimum in other, right? So I can partition it like this: 1, 2, 4 and 3. Just see what I mean to say is, when whatever is the minimum difference between adjacent elements, you do one thing: you place one element in one array and the second element is the second array. That's it. Simple. That's what we need to do. Okay, and that is how we can simply solve this problem. In this case, like for example, suppose 4 and 3 were the elements, adjacent elements which has minimum difference. So you place 4 and 3 in separate arrays. Now these 1 and 2, right, you can place it anywhere. For this example you can place it anywhere. Let's come to a better example, right? So here if you sort the array, what do you get? You get 1, 10 and 100. Let's see the difference between adjacent element. This is 9, this is 90. Okay, this is 9 and this is 90. What I'll do, this says that this element and this element should be in two separate arrays. So 1 here, 10 here. Now what's the possibility of 100 here, right? If I place 100 here, what do I get? The maximum here, right? And minimum here, or minimum here and maximum here. In that case I am good to go if I take minimum here and maximum here. Okay, what's the other option? 1 here, 10 here, and you place 100 here. What will happen? Okay, you take minimum from here and maximum from here. So what I mean to say is, from whichever array, right, from whichever array you are trying to take maximum, you place all the larger values there. In short, you do not need to actually place the values. It's just that whatever is the minimum difference, that will be your answer, right? Because you will, if you would have to do it, you would be placing elements such that these two elements are the result of those two arrays, right? For example, either minimum of a particular array is this or this, and vice versa, either the maximum value of an array is this or this, right? That's it. That's the simple thing you need to do. Like for example, I know if I place 1 and 10 in two separate arrays, okay, be it nums1 or nums2, then the maximum of one array should be either 1 or 10, and in that case the minimum of the second array should be 10 or 1, right? If minimum is 1, maximum should be 10, right? If maximum is 1, minimum should be 10. Okay, this is minimum, this is maximum. That's what we need to do. Now remaining elements you can place accordingly, but actually you don't need to place it, right? The difference will be your answer. So that's what I have done here. Just sort the array, initialize your answer with the maximum possible values. Okay, start comparing the adjacent values. You start from index 1. So math.min of answer, nums of I minus nums of I minus 1, return answer. That's your solution. And I've already told you why this is your solution, right? Because whatever is the minimum difference, right? You can place the element such that one element becomes the max or min of one array and the second element becomes the max slash min of the second array. That's it. That is why you are doing it, right? So yeah, this was a relatively simpler problem as compared to the first one of the same contest. So I hope you learned something new from this video. So yeah, do support it by giving a thumbs up. Do subscribe to the channel as well. In case you have any queries related to the solution, mention that in the comment section. I'll revert on each one of them. Thank you. Take care. Bye bye.